In electrostatics, we have got a principle called the principle of conservation of charge. So this principle here states that the net charge of an isolated system remains constant during any physical process. What is the net charge, first of all? Welcome to Edu-ca-te. So today we're going to be talking about the principle of conservation of charge, which states that the net charge of an isolated system, remains constant during any physical processes. I'm sure we have already uncovered what physical processes electrons can be transferred from one object to another. So the principle of conservation of charge states that the total of the charge, which is the net charge, by net charge it just tells you that the total of the charge of an isolated system remains constant. So it means that the charge that is transferred from one object goes directly to the other object without being lost. So it means the charge is what? It is conserved. So e.g. here it says when an identical object with different charges touch, charges will be transferred between the conductors. So the two conductors will have what? Equal charge. So if you do not understand the method of contact, please do rewind on our video when we explain the second method of the transfer of electrons from one object to another. So here, the two conductors will then what? Have equal charge. So here is an example. So we've got two identical charges on insulated stands. So two identical charges, remember that we said that there can only be a transfer of electrons when the charges are identical. By identical, it means that they're of the same kind. So here we're having two identical objects. Let's name this object A and let's name this object B. So object A, what is the charge of object A? So the charge of object A is plus 5 microcoulomb. So microcoulomb, what is microcoulomb? Okay, we've got object B, which has got what? Which has got minus 9 microcoulomb as well. Okay, so these are the magnitudes of the charges or the sizes of the charges of these two objects respectively. So those objects, they touch first of all. So remember, when you hear this keyword touch, just know that the objects they are going through the process of contact. So they move apart again. So determine the new charge on each. A, the amount of charge transferred. B, and C, the amount of electrons transferred. So we need to solve all those three questions. So pay attention. So here we have got the magnitude of the charges. Remember that the unit for charge is coulomb, not microcoulomb. So what do we do about this M? So that M is actually telling you, it's actually a prefix. It's actually telling you a certain magnitude is actually equals to a certain number. So when you've got a smaller M, it means it is equals to 10 to the power of minus 3. So it means that you are multiplying plus 5 with 10 to the power minus 3. Always when you've got a smaller M. And then you have to remain with what? With coulomb on its own. So this is how we convert from an M to a coulomb. So here, first of all, we're having what? We're having a charge of plus 5 times 10 to the power of minus 3 coulomb. We have replaced M with 10 to the power minus 3. So this is same applies for this one, times 10 to the power minus 3 coulomb. So how do we see that the charges are identical? We see by this measurement tool, which is minus 3, and then over there is what? It will show minus 3. So that tells you that they are of the same kind. That's why we have got a microcoulomb on each of them. So let's actually analyze the charges. We've got a plus 5, we've got a minus 9. So by plus 5, it tells you that this object A is positively charged, meaning that the number of protons in it is bigger than the number of electrons in it. On object B, it is a negative charge, meaning that the number of electrons in it is bigger than the number of protons in it. So I hope you understand. So this one is positively charged, and then this one in red is negatively charged. So here, first of all, we want to do the quantization of charge, or the sharing of charge. Remember that these things touches each other, meaning that there's a contact between those two things. Remember, the aim for a contact when two conductors are actually in contact, their aim is to actually transfer electrons from the conductor with higher electrons to the conductor with lower electrons. What is the goal? Is for them to have equal charges. So it means if this one is +5, then this one also must be +5. But then how do we make them equal? Let's actually see which one has got more electrons. So here, this one has got more electrons since it's negatively charged. So it means electrons will be transferred from object B to object A. Reason being, this one has got excess, this one is electron deficient. So first of all, how do we see the new charges on each? So question A asked us to actually determine the new charge on each of them. They say it on each because they know that after the transfer of electrons from B to A, their charges will be equal to one another. So here, the new charge, first of all, the new charge on each of them will be equals to the sum of charges in A and B over 2, since they are 2. So here, the new charge, we're actually going to look at charge of A. Charge of A is +5 times 10 to the power minus 3 coulomb. We add it to the charge of B, which is -9 times 10 to the power minus 3 coulomb, and then we divide it by 2. Reason being, we want to see what is the new charge on each of the conductors after they've separated from the contact. So here we've got the Q new. The Q is actually a symbol for charge, and then the new is actually the new charge on each of them. So if we are going to work out our math over there, we'll have -2 times 10 to the power of minus 3 coulomb on each. Do mind the statement on each. It's very important because this is the new charge on each of them after the contact. Remember, their charges are equal. And then now, let us go to question B. We are done with A. So question B asked us that we must calculate or determine the amount of charge transferred. Okay, so the amount of charge transferred is not the new charge. No, we want to see exactly how much did B transfer to A. So we do a change formula. So there is what? There is a change of charge. So we're going to do what? This formula called delta Q is equals to the QF minus QI. What is delta? So this triangular thing, this triangular shape is just telling you that it is what? It is a change in something. This Q is telling you that this is a charge. And then this F is the final charge. And then this I is the initial charge. Let's look at the terms. So here, the change in charge, meaning that how much charge has actually changed here, or actually how much charge has been transferred from B to A. Remember that the amount of charge that has been transferred from B, it will be the amount of charge that A receives. So we can use any of them over there. So the Q final, we're talking about the charge which we have at the end. And then the initial is the charge which we have in the beginning before they come into contact. So here the change in charge is equals to the final charge which we have at the end, which is -2 times 10 to the power minus 3 coulomb. Remember that charge, it is the same for all of them. So it'll be what? -2 times 10 to the power minus 3 coulomb. That is the final charge which we have. We have substituted it. So here, we do what? We do subtract the initial charge. So many people might actually be puzzling as exactly what charge are we going to put at QI? Is it charge of B or charge of A? Remember that this is the principle of conservation of charge, states that the charge that is transferred from B to A, it is the charge that A will receive. So it means you can use any of them over there. You can use the charge of A as initial charge or the charge of B as initial charge. At the end of the day, the charge transferred from B is equal to the charge that A receives. So Q initial, let us go and look at one charge which we can use. Okay, let us use one example over here. What charge can we use? Okay, let's use the charge of A. So the charge of A, it is what? Positively charged, remember? So we have to mention that it's +5 times 10 to the power of minus 3 coulomb. So here we want to see what is the change in charge. What changed? That is what the change in charge meant. So what changed in A? We want to see here how much did A gain from what? From B. So the charge gain here is minus 7 times 10 to the power of minus 3 coulomb. So this is the amount of charge that has been transferred to A. So if we were to substitute B here over here, you would what? You would find the amount of charge that has been what? That has been actually been given off by what? By object B. So here you can substitute the charge of B or the charge of A, because the charge that is coming from here to there is equal to the charge that is being received by A. So this is how you calculate the change in charge. So this is delta Q is equals to QF minus QI. Let us go to question number C. So question C asks us to calculate the number of electrons transferred. The charge and the number of electrons transferred, it is different, but then it correlates in some way. We have to first look at how much charge does one electron have. So each electron has got a charge of, one electron has got a charge of negative 1,6 times 10 to the power of negative 19 coulomb. So it means whenever you find one electron, the magnitude or the size of its charge is minus 1,6 times 10 to the power minus 19 coulomb. So here we want to see how many electrons have been transferred. Remember, this is the amount of charge transferred. I was actually supposed to write here transferred. So here we want to see how many electrons have been transferred if we have got such a charge called minus 7 times 10 to the power minus 3 coulombs. So here we've got a formula called Q is equals to NQE. So QE represent here the amount of charge each single electron has. And then Q, it is what? It is the charge transferred. And then N is representing the number of electrons transferred. So this is all about the transfer of charge from one object to another. Since we know that this charge, this amount of charge, the change in charge is the amount of charge transferred, which is minus 7 times 10 to the power minus 3, we're going to substitute here minus 7 times 10 to the power minus 3 coulomb is equals to the number of electrons which we do not know. Remember, our question asked us to calculate the number of electrons which we do not know. So here, N times QE. So each single electron, no matter what element it is, no matter where you find it, the QE charge is what is always constant. So it means each single electron has got minus 1,6 times 10 to the power minus 19. It does not change at all. So here, what can we do? Are we allowed to say that N is equals to the amount of charge? No. We have to eliminate this minus 1,6 times 10 to the power of minus 19. Minus 1,6 times 10 to the power of minus 19. Therefore, your number of electrons transferred is equal to 4,38 times 10 to the power of 16 electrons transferred. So this is how you calculate the number of electrons transferred. Then we're done. Thank you for watching. Don't forget to subscribe, tell your friends.